Hello everyone. Today again we will learn uh, another topic from the chapter ray optics. So today we will learn about image. To know the ray optics hard problems properly and to solve them, to build a concept on ray optics, we will try to go step by step. So that's why I am just revisiting this topic on image. I think this will give you a broad idea about what is an image and how does image is formed and so on. So let's start understanding the formation of an image. To understand an image, what are you going to do? Let me draw a mirror first. So this line represents a mirror, and let us define an object. Yeah, let me do it here. This is an object O, which is placed in front of the mirror. Now I will draw. So these are the incident ray which is traveling coming from here. I'm considering one such ray which is coming from O and incident on the plane mirror. After reflection, this ray moves along this side. This we have learned in last lecture that according to laws of reflection, the angle of incidence is equals to angle of reflection. That is, this angle is equals to this angle, right? The angle of incidence and angle of reflection both are equal. The rays coming from here, and here is the person who is looking at the object from here. So for this person, the object is located where? Is it located at point O? Let me name this point as A, this point as B. The object located at O, A, or at B? Where is it located? To understand this, to understand and let me to explain you the concept of image, I will draw one more ray which is incident normally on the mirror. This is 90°, so it retraces path backward. So this is 90. As a result, what will happen now? When this person is looking at the mirror, he will see that the object is located somewhere here. This is the point where if we extend the line from C to I and from A to I, they intersect at the point I. Now you can easily prove that this angle, that triangle OCA, OCA and triangle ACI, ACI are similar because you can see this they have the common, the angles are 90° and so on. I'm not going to that right now. So this is the point where the two rays is appeared to be coming from. This point is called the image. The person looking at the mirror will find the object O is not located at its own position, rather than it is located at the point I. This is the concept of image. Now in case of plane mirror, the object distance U is actually equals to the object distance V. So we can write like this way also. For plane mirror, U equals to V. Mod means the minus, or u equals to minus b. If this side is plus, that side is negative, and vice versa. So this is the concept of image. This image is a virtual image. Now the one question arises here. We see that the plane mirror has formed a virtual image. So does it form a real image? I will answer this question at some point in one particular lecture, not right now. After we have completed the spherical mirrors, we will try to understand, does spherical mirrors as well as plane mirror, do they form real images or not, and under what condition they will form. We will look into this matter later. So I hope you understand that what is a concept of image. You to find to ray trace the image, you minimum you need two rays to form the location of the image. So okay, now our next topic. Now next we're going to learn different type of images. Let's see different type of images. Now image can be classified into two categories: real image and virtual image. In your junior classes, you have learned that any kind of image which you can observe, which you can take it on a screen, we will call it a real image. And the opposite, the image which you cannot take it on the screen, is called the virtual image. This definition is well and good, but we'll try to understand uh, from the higher secondary point of view what are the definition is helpful to understand the concept of real image and virtual image, because we will be always doing it ray diagrams and so on. So in that case, we need to understand its other definitions. We need to know its other definitions. So one such definition would be, real image definition would be that after reflection the rays of light converge to a point. So what is this? I hope you all have the basic idea of a spherical mirrors. As I haven't discussed spherical mirrors yet, but still I am assuming that you know about what is a spherical mirror. To let us see, I will draw one. I will draw one spherical mirror here. This is a concave spherical mirror, and I will consider one point object. Very point object out here somewhere on the principal axis. Not necessarily has to be at the center of curvature or radius. Not necessary. Now a ray starting from here will be incident on the mirror. So after reflection, it will follow somewhere here. Similarly, from this object, another ray will be going. After reflection, it will also pass through this point. So this is the object distance, this is the object, and this is the image. You can see the definition says after reflection the rays of light converge to a point. You can see clearly the ray originating from O, after reflection it is meeting at a point I on the principal axis. This point I is the region of real image. It will be inverted and you can take it on a screen. Similarly, in case of virtual image, what it says, after reflection the rays of light appears to diverge from a point. So let us see how the picture ray diagram will be. We are going to consider here a diverging mirror, that is a convex mirror. This is a convex mirror. This side it is silver. Now I will consider one object. So here is the object. Now the rays which are originated from here will be incident on the convex mirror, and it will get converge out like this. If a ray traces backward, it meets the principal axis at the point I. Similarly, we can have one more ray here. We can see it again retraces back. This one also will be passing through. So this is my object, this is my image. So what does the definition says? Definition is, after reflection the rays of light appears to diverge from a point. Yes, if someone is looking at from here, if someone is looking from this point, if this here is the someone is looking, eye is there, if someone is looking from this point of view, you'll see that the object is located at I, which is a virtual image, and O is the actual position of the object. This is a virtual and erect image, virtual and erect, and in this case this was real and inverted. Inverted image. Okay, so this is the real actual concept that we're going to use now in case of ray optics. That in case of real image, rays of light converge to a point, and in case of virtual image the light appears to diverge from a point. Understand? Let us see one example for real image. I'm using one picture from the Wikipedia. You can see here the person is holding one convex lens in front of a house. The image of the house through the lens is real and inverted. Now you can ask, where is the screen? If you look close, your eye, which has a retina, is acting as a screen. That's why you're seeing this as a real and inverted image. Now in case of virtual image, a very easy example would be image of a person, image of a person on a plane mirror. As simple as that. Plane mirror. Everyone has stand in front of the plane mirror and have seen yourself. So that image is actually a virtual image. It is erect and it is virtual. Okay, this much of introduction with images will be fine. Let's see you in next topic. Thank you.